All right, I'm going to go through two more Heron's theorem problems with you. So if I wanted to find the area of this triangle, my first thought would be, could I use 1/2 base times height? And so I could use 9 as the base, but the height would have to drop down and be perpendicular, and I have no idea what that number is. So if I use 10 as the base, well then its height would go this way, so it's perpendicular. But again, I don't know what that height is. And last but not least, if I wanted to use the 6 as the base, then here would be its height, which again, I don't know. So this is where Heron's theorem comes into play. Now the area formula for Heron's theorem is ginormous square root S times the quantity S minus A times the quantity S minus B times the quantity S minus C, where A, B, and C, little a anyway, big A is area, little a, little b, little c are the three side lengths, which in this case are 6, 9, and 10, and they don't have to be in any particular order, but typically I'll call little a the smallest side, little b the medium side, and little c the longest side, but it truly doesn't matter. And S in this problem represents half the perimeter. Okay, so to do this problem, let's see, what is the perimeter? What is the distance around? So 6 plus 9 is 15, plus 10 more makes 25. So we get a semi-perimeter, is what S really represents here, of 12.5. So sometimes your semi-perimeter, depending if your perimeter is even, will be a whole number. And if your perimeter is odd, like 25, then the semi-perimeter is going to be a decimal, something 0.5. So now if I consider plugging this in to Heron's formula, because now I know what S, A, B, and C all are, I'd have the square root of 12.5 times the quantity 12.5 minus, we'll go 6 for the smallest side, times the quantity 12.5 minus 9, the medium side, times 12.5 minus 10, the longest side. Now, if we see what we got here, we still have a 12.5. 12.5 minus 6 is what? 6.5. 12.5 minus 9 is 3.5. And 12.5 minus 10 is 2.5. Now, these are all really ugly numbers to work with here. Could you end up turning this into a simplified square root? You could. It's not necessarily the easiest thing in the world to do. So what I would do in potentially this case, and if you could figure out how to do this as a simplified square root, then I would love that more than anything. But what it would turn out to be, let me just get some space in here. You would want to turn that like 12.5 into what it is as a mixed number, or not as a mixed number, as an improper fraction. So 25 halves is 12.5 times 6.5 would be what? 20, no, that's not right. 12.5 is, yeah, it's 25 halves. 6.5 would be 13 halves. 3.5 would be 7 halves. And 2.5 would be 5 halves. Well, then you could multiply all your numerators together. You could multiply all your denominators together. That top number isn't really going to be anything too terribly friendly here. But you could take the square root of each individual value. So if I had the square root of 25 times the square root of 13 times the square root of 7 times the square root of 5 all over, square root of 2 times square root of 2 times square root of 2 times square root of 2, well, down here, you could get a 2 out of that. You could get another 2 out of that, which altogether in the denominator gives you a 4. 4. And then, hey, this square root of 25, that's a nice 5. But 13, 7, and 5, the remaining square roots are all prime numbers. So you just multiply them back together into a singular square root. So let's see, 13 times 7 times 5 is 455. So a fully simplified area would be 5 from that square root of 25 times the square root of 455, which is where the 13 times 7 times 5 went into, all divided by 4. Now, that's the exact answer. And that's what I would love for you guys to be able to do. But let's say you want to get an answer, but you're not willing to go above and beyond because, I don't know, I thought you were in pre-AP geometry. But if you had the square root of, and if we went back to those decimals, 12.5 times 6.5 times, I got to remember what all my different numbers were, 3.5 and 2.5. You could just go to your calculator and really just type all this in, and then just get what that comes out to be as an approximate decimal. So if I were to go to my calculator, hello calculator, you may not necessarily have a TI-84 here, but we could type in square root and then go 12.5 times, what would we say, 9.5? Was it 9.5? No, 6.5. 6.5 times 3.5 times 2.5, and we get 26.66 if I go 2 decimal places. So all of this approximates to 26.66. Hey, guess what's true about 5 times the square root of 455 all divided by 4? I better get this number. So let's just double check and see here. So 5 times square root 455, and then divided by 4, and it's the same exact number. So I can feel confident that my exact square root answer is really the same thing as my approximated decimal answer. So I would be okay with either one of those methods. Obviously, I would love to see the simplified square root answer. Now, let me show you another example that's not going to be fun to do, and I would highly encourage you just to use your calculator and get some decimal values. All right, so starting with this one, square root s times s minus a times s minus b times s minus, oh, forgot my parenthesis, s minus c. Again, where s is half the perimeter. So here, what's the perimeter? Well, we've got a 5, we got a 6.5, 6.5, and we got a square root of 5. Now, we can add 5 and 6.5 to get 11.5, but I can't add 11.5 and the square root of 5. They're just not like numbers. So do I just say s is equal to half of the quantity, 11 plus 5 plus root 5? That's going to get really ugly if I have to plug that into 4 places into Heron's theorem, Heron's formula. So what would you do in this scenario? And this is where I would just go use the calculator. So let's figure out what S is approximately. So let's go back to our calculator. So if I took 11.5 plus the square root of 5, and let's see what that is. So that's the full perimeter, 13.74 rounded to 2 decimal places. But I got to divide it by 2 or cut it in half. So S, the semiperimeter, is 6.87 rounded to 2 decimal places. 6.87. So there's my approximate value for S. So now, if I go use that, let me at least get rid of these first 2 lines here. If I were to go plug this into Heron's formula, then I'd have square root of 6.87 times 6.87 minus one of my sides. And again, it doesn't matter which one. Square root of 5 is technically the smallest side. Times the quantity 6.87 minus another side. So I'll just pick 5 since it's the medium. And 6.87 minus the longest side, 6.5. Now this for sure isn't going to be fun to try to simplify in any way. So again, I would just type all of that into my calculator. And you can do it little bits by little bits until in the end you're doing the whole thing. But I'm going to type it all in into one shot here, to the best of my ability. So square root 6.87 times, and then I'm going to use parentheses here, times the quantity 6.87 minus the square root of 5, and then I'm going to put an end parenthesis on that quantity, times quantity, 6.87, minus 5, end parenthesis, times beginning parenthesis, 6.87, minus, what do we say, 6.5. End quantity, and then enter. And all of that comes out to be approximately 4.69 to 2 decimal places for that area. So I can just act like I did all this stuff in my head and go, hey, all of this comes out to be approximately 4.69. Was it 4.69? I can't remember. Yeah, 4.69. Perfect. So there is the approximate area for this triangle. And again, we couldn't have used good old 1/2 base times height, because if we had picked any side as the base, you don't have a value for the height. So we had to use Heron's formula. So hopefully you got a little bit more out of that. You can see when you get some rather sticky numbers in Heron's formula, it is perfectly okay to start approximating to decimal places. And I would prefer 2 decimal places. All right. So there's your 2 examples. And then you might see another one on a quiz soon. Goodbye.